Hello, we're busy doing internal resistance in class. So we're going to do a prac that shows the internal resistance of the battery. Yes, I'm going to use a series circuit, so I'm going to connect both sides, and I should get the light bulb to glow. If I don't get the light bulb to glow, then I've done something wrong. So I'm just going to swap it out for another light bulb very quickly. So when we talk about internal resistance, there are two things that we're speaking about. We're speaking about the EMF, and we're speaking about the voltage when a load is attached. All right. What is the maximum or the biggest value, grade 12? That's you. You guys are the grade 12s. Sorry? No, what's the maximum value? EMF or voltage with load? The EMF is the bigger number. Alright, so the EMF is the bigger number. We've got our series circuit to work. Okay. When I want to measure my EMF, my switch or my circuit needs to be broken. Remember, EMF is a measurement of the output of the battery without a load attached. Makes sense? So I'm going to disconnect that, and I'm going to add in my voltmeter. Voltmeters are connected in series or parallel, grade 12. Bless you.
Thank you.
Somebody sneezed in the video. All right. How are voltmeters connected? Series, parallel?
Parallel.
Parallel. Okay, so voltmeters are connected in parallel. Can somebody tell me why?
Because it needs to measure the difference.
Sorry? Why in parallel? Yes, it does have a high internal resistance. That's excellent. And it needs to, you're both correct. You've mentioned that it needs to measure the potential difference across something. If you look at the meter, I have a reading that goes the other way compared to 0. In other words, it's going in the wrong direction. So that means the polarity needs to be swapped around. Yes? That just means that the two things need to be different. I'm getting a very big reading because I'm using a scale of 0 to 3. And actually I have 2 cells involved, and as Bolu mentioned before, each cell is going to be 1.5-ish, which means I'm going to change to get a different scale to get a better reading. And so my reading right now is just over 3 volts. And if my reading is just over 3 volts, that means that firstly the cells are in great condition, okay? And that means that we're measuring them in series added up as the two, 1.5 and 1.5. What I'm now going to do is I'm going to connect the circuit. Okay, so I'm going to connect the circuit. I just need to do something very quickly. I'm going to move that there. Okay, so I get my reading, and now I'm going to connect my circuit. So this measures the EMF. Now when I close my switch, I'm going to get the voltage for the load. Have a look at the reading on the voltmeter. This is the most important part. So once that's connected, do you notice that there is a definite voltage drop? Okay. In other words, the potential difference decreases. So the voltage drop is the voltage lost because of the internal resistance of the battery. Yes? We now have current flowing, which means the internal resistance of the battery has kicked in. And we're going to use a variety of different formulae to calculate this. Specifically, we're using Ohm's law. So we're using V equals I times R, okay? If we're talking about the voltage dropped inside of the battery, that means we need to use the current times by little r, or the internal resistance of the battery. I need someone to just write down the 2 readings for me so that we can work this out, to work out the internal resistance of each battery. The first one, the first reading, the EMF reading, oopsie daisy, I took the wrong thing off. You can write it on the board, my angel. The EMF reading, shall we call it 3? It's like just on 3 right now. Can you see it? Everybody see it? It's on 3. I'm using the top line. Yes? So we've got 3 volts. Load, in other words, the voltage when the switch is closed. That reading is, it is 2 away from 3. Do you understand the scale on this particular meter? The measurement is from 0 to 3 on the meter, which means each of the lines in between, there are 10 of them, each of them count for 0,3. Are you with me with that?
Yes.
Yes? So the scale means that each division counts 0.3. What that means is that if I have this reading, I'm going to use 8 divisions times by 0.3. So write down 8 divisions times by 0.3, and that will give us our reading. Does anybody have a calculator for that? I see Andrew's ready.
Andrew?
2.4. So our voltage load is now 2.4. I'm going to need a current reading. Pause for a second. About the rest anymore.
Yes, yes.
Okay, so we're now going to just measure a current reading in the actual circuit, and the reason for that is because I want to be able to calculate the internal resistance of this particular battery. I'm going to do this by disconnecting the cell itself. Disconnecting the circuit itself. The reason is because ammeters are connected in series. They're connected in series because they have a very low internal resistance. Yes? And their low internal resistance means internal resistance means what?
That the current can just flow through without it being
That's
affected.
right. So if we put it into parallel, it wreaks havoc. All right. There's my reading. I have a scale of between 0 and 500 milliamperes that I'm using. So I'm going to read the scale that goes from 0 to 500 milliamperes. Do you see it? Okay. Which means when I take the reading, does somebody want to come and help me take a reading? It's on 200. 200 milliamperes. So we've got a reading of 200 milliamperes. Okay. Are we good? And that's where we're going to stop our video for today. We're now going to do a calculation, and we'll restart when we do the calculation. Good. Okay, so now we're going to do the calculation that relates to this particular crack that we've just done. I'm going to draw the circuit diagram first. So we have 2 cells. Okay, and those 2 cells are connected to a light bulb. Let's put a light bulb in. And remember, we took a reading in terms of a voltmeter. Yes, and we had current in the circuit as well in terms of an ammeter. We took 2 readings. We did an EMF reading, and then we also did a voltage for the load reading. Okay, so that one was the one with the load, and then this one, I didn't actually have a switch in, but I did disconnect the bulb when I took the reading over here. Okay, remember the one with the switches open is going to be my EMF reading. So the EMF for this was 3 volts, okay? And then for this one, the voltage with the load was 2,4 volts. Are we all okay with that? You right, Naz?
What's load?
The V load means that load. Okay, you understand V load? Yes. And then remember that the current reading here was given to us as 200, but it's milliamperes because my measurement or my reading was on milliamperes. Now I want to calculate the internal resistance of the actual cells or of the battery firstly. I'm going to use the equation that's given to me in my textbook. So I can use EMF being equal to the voltage, for the load, added to the voltage for the internal resistance. Yes? Okay. Now I've got the bits and pieces already. So I have this value as being 2,4. Yes? I'm looking for this, but I don't have the bits and pieces for it. I'm going to use I times little r. Yes? And I have the value here as being 3 volts. I have the current reading, so I can say that's going to be 2.4 plus the current reading of, it's 200 milliamperes, so it's going to be 200 times 10 to the power of minus 3 times r. Are you okay with that? Let's get a value for the internal resistance out, please. So it's 0.6 divided by 200 milliamperes. How much? 3 ohms. So I end up with 3 ohms as my internal resistance of the battery. So that is my internal resistance. And this is for the whole battery, hey? But we've got 2 cells involved in that battery, which means that, therefore, it's the 3 ohms divided by 2, which is 1,5 ohms per cell. Are you happy with that, grade 12s? Okay. Pauline? Questions? No? Alright, so we're done. We are now done.